Note 7-3, factoring with the greatest common factor. So you guys should have learned previously GCF. Okay, do you remember GCF? Do you remember greatest common factor? Okay, anything like that. Okay, so we got to start from the beginning, huh? Here we go. The greatest common factor is the greatest term that divides evenly into a set of terms. Okay, so it's the greatest number, right? So last week, what we learned was how to distribute with a variable on the outside, remember? Distribute and combine your like terms. We also learned how to double distribute, remember that? Okay, double distribute where you drew the 2 arrows over the top and the 2 arrows under the bottom. Are y'all with me? Do y'all know what I'm talking about? Okay, double distributing. So the rest of this unit is working backwards. Okay, so whatever we did at the first half, the first 2 days, now we're going to take what we did and we're going to do everything backwards. All right, and I'll show you how that works in just a minute. Okay, it says find the greatest common factor. Okay, so that's our keyword today, greatest common factor. Okay, greatest common factor is our keyword. That's going to be called my GCF, is what I'm calling greatest common factor, GCF. So it says find the greatest common factor in each of the following. So I have 8 and 12. So what I want you to do is we're going to factor out 8 and 12. I want all of the numbers that multiply evenly into 8 and 12. Okay, well, what is the first number that goes into 8? 1. 1 times what? 8. Okay, notice how I put the smallest number in the front and the largest number that can go into 8 is 8 and it goes in the back. Okay, so the smallest number in the front, 8 in the back. Now why am I doing this? Because I'm going to keep them in order, least to greatest. Okay, so after 1 is 2. Can 2 go into 8? Yes. 2 times what?
4.
4. And 4 is going to go in the back. So smallest, biggest, next. Okay. My next number is 3. Can 8 be divided by 3? No. You get a decimal, so that's not a factor. Then after 3 is 4. Can 4 go into 8? Yes, and I already have it there, so I'm done with the factors. Okay, that's all the factors that can go into 8. Okay. Then I'm going to do 12. So first number is 3. Can 1 go into 12? Yes. 1 times 12. And I put 12 in the back because it's my largest number. Then I move to 2. Can 2 go into 12?
Yes.
Cameron, you should be writing. Yes. 2 times what? 6. Then I move to the next number, 3. Can 3 go into 12? Yes. 3 times 4. And then 4. Can 4 go into 12? Yes. It's already on here, so I'm done. Okay. Now, I want to know the greatest common factor. Well, these are all factors of 8 and all factors of 12. Well, the greatest common, what's common mean?
4.
Common means that they both have them. And I want the greatest common.
4.
The greatest common is 4. Do they both have 1?
Yeah.
Do they both have 2? Do they both have 4?
Yeah.
Yes, but the biggest is 4. So my GCF is 4. Got it? So right now I'm just finding the greatest common factor. Okay, number 2. Now why is 2 different? It has exponents. I don't today. Okay, thanks girls. Okay, why is number 2 different? Levi, please don't act like that. There what? There's exponents. What else is different? Variables. Variables with exponents. Okay. So with variables, x to the 5th, I'm going to expand them. How do I expand them? Listen, x to the 5th. How do I expand that? X times x times x times x times x. 5 times, right? So I expanded it. And then I'm going to do x to the 3rd, x times x times x. Okay, so what's the difference between numbers and letters? What do I have to do with the numbers? Factor, right? I had to get the numbers that multiply together. And letters, what did I do? I just expanded it. Okay, all I did was expand it. Now, I want to know my greatest common factor between x to the fifth and x cubed. So how many do they both have in common? Well, they both have this in common. They both have this in common. And they both have this in common. So my GCF, how many do they have in common? X to the third. They both have 3 in common. What do you think my trick is going to be with letters with exponents? How could you do this without having to expand it every single time?
Just take the lowest number.
You just take your lowest exponent. Okay? So I couldn't take the highest exponent because x to the fifth, do they both have 5 x's in common? No. Listen. I can't take the highest exponent 5 because this has 5 x's, but does x cubed have 5 x's? No. If I take the lowest exponent 3, do these have 3? Does this have at least 3? Yes. Okay. So with variables, Ethan, stop talking. With variables, we're going to take our lowest exponent, and that's going to be our GCF. So look at number 3. Okay. I have a trick for you to find all of your factors. Are you ready? Okay, turn on your calculators. Why is number 3 different, by the way?
Because it has a number and
It's got a number and a variable. Okay? So first I need to know all the factors of 16. Okay, so 16. Now, how I'm going to show you to do this is we're going to go to a graph. So everybody go to a graph, and you're going to need to know how to do this, so make sure you're doing it with me. Anytime I want to know the factor of something, all the numbers that multiply together to give me 16. Okay? Anytime I want to know the factors, I'm going to put that number, so 16. Everybody put 16. And if I want to know the factors, I'm going to do 16 divided by x. It's always going to be divided by x. Hit enter. Now this weird graph pops up, but I don't care about the graph. I'm looking for a list of numbers. So where am I going to go for a list of numbers? Control T. Okay, now, it gives me a table, but in the table I want you to notice, what's 1 times 16? 16. Are those factors of 16?
Yes.
What's 2 times 8? 16. We don't care about decimals right now. We only want whole numbers. 4 times 4? 16. That's a decimal. Don't care decimal. 8 and 2? 16. I've already talked about 2 and 8. Okay? So, my factors are 1 and 16. What's the next one? 2 and 8 and 4 and 4. So there's my factors of 16. Are you with me? Okay. Now, I want to know the factors of 20. So, don't click anything in the calculator yet. Okay? I want everybody to stay right here. If you've clicked away, I want you to go back to this. If you're not in this spot with me, I want you to go back to this. Okay. I want to do Control T. Get away from that. Hit Tab. And now I want to do 20 divided by x. I still want the 16 in there, okay? So 20 divided by x. Then go to Control P. Now, how many tables do I have in here? 2, okay? This one in blue. Does everybody see how it says 16 divided by x?
Yeah.
That's all my 16 numbers. So I'm not worried about those right now. I'm not looking at those. I'm now looking at my 20 divided by x. Okay, so my factors, 1 and 20. Write it. Then I have 2 and 10. 3 is a decimal, so that doesn't matter. 4 and 5. 5 and 4. I've already got those, so I'm done. Now, I want my greatest common factor. So which one do they have in common that's the biggest? 4. So my GCF is going to be 4. Now, that's the number. Don't forget you still have M's. Do they both have an M? Yes. Do they have M in common? Yes. So that's going to be part of it. And what's the smallest exponent? 2. So that's my GCF right there. Okay, now look at your calculator. Why did I want you to put them side by side? Am I going to make you write this part out every single time?
No.
No. I'm not going to make you do that. That's a lot of work, especially when it's just written right here for you. Okay? All right, so look how I'm going to show you to do this. Look up here so you don't have to write it out every time. List all those numbers out. I'm going to start on my first column. Okay, right here. For 1, do they both have whole numbers, 16 and 20?
Yes.
Yes. What about 2?
Yes.
So far, what is my GCF? 2, because they both have whole numbers in common. Levi, please stop. What about 3? Does 3 work?
No.
Why? It's a decimal, so that doesn't work. What about 4? Does 4 work?
Yeah.
Yes. Why does 4 work? They both have whole numbers. Does 5 work?
No.
No, because it has a decimal. 6?
No.
No. 7?
No.
8?
No.
It's got a decimal. 9, decimal. 10,
Nope.
decimal. Okay. And so on. And you can go all the way to 16. Because 16 is going to be the greatest one because my smallest number is 16. 16 and 20, smallest number is 16. Okay? So the highest number that has both whole numbers was what? 4. So 4 is my GCF because both 16 and 20 both have whole numbers in their columns. Okay? So that's my GCF over here is 4. And then you do your variable after. Okay? If you're able to look in the calculator and say, what's the highest x that has whole numbers in both columns, and you can do that finding your GCF, then that's fine. Please stop, Levi. I'm about to have to ask you to leave because you're being very distracting. Okay? Do you understand? And you need to know how to do this, so I want to keep you in the room, but you also can't be a distraction. Okay? Thank you. If you have a hard time looking and deciding which one both has whole numbers, you can always write them out like this, one at a time, and then decide with them written out. It's up to you. Everybody understand? Okay. Number 4. Okay. I need to know the GCF between 56 and 32. So I'm going to go to a new graph. Everybody go to a graph. Okay. Go to your new graph. 56, and what do I plug in? 56 what? Divided by x. And then I'm going to hit tab and do 32 divided by x. So I should have 2 lines on there. Now where? Control T. And it's going to tell me all my factors. Okay, does 1 work?
Yes.
Does 2 work? Yes. Does 3 work? No, because it has decimals. Does 4 work? Yes. 5?
No.
No. 6?
No.
7? 8? Does 8 work? Are both of those whole numbers? Yes. So 8 is the highest number so far. Does 9 work? 10? Decimals, 11, decimals, 12, decimals, 13, 14, 15, 16. Okay, and I don't have another one that has 2 whole numbers. So what was my GCF? 8 was the highest number that had whole numbers in both columns. Okay, so my GCF, you guys told me was 8, was the highest x that had both columns as whole numbers. Do they both have a C in common?
Yes.
Yes. And what's the smallest exponent? 2 or 1? 1. Just regular C. Good. Questions? Okay. All right. Now, right here, we're not finished. That's just one little part of what we're doing today. Okay. All right. It says multiply. So we should all know how to do this. How do I distribute this? 4x times x gives me what?
That would be 4x.
4x squared. Okay. Then I distribute the 4x to the 5. 4x times 5. Positive 20x. Okay. That's what you should know how to do. Okay. We talked about this all last week, right? Okay. Remember how I said we're going to go backwards from here on out? Okay. So now, this has been your answer. This is what you've been trying to come up with, your answer. Today, I'm going to give you the answer, and I want you to be able to work backwards and find this. Okay? So look what it says right here. Factoring is the opposite of multiplication. So what is factoring? Dividing. So factoring is really just dividing. So when we've been multiplying, we've been distributing and multiplying to each term. Now we're going to divide each term. Okay? Then I want you to also put this right here. See this right here? See how I circled the 4x right here? Today, that's going to be our GCF. That's going to be our GCF. So you guys know how you just found your GCF up here, right? That's what we've been doing. That's where we're going to put our GCF right here. Are you with me? Okay. So what I did was I took 4x and I multiplied it to the x. So this right here contains this 4x in it because I multiplied it. Right? Then I took the 4x times 5. This right here contains 4x in it because I've multiplied it to the 5. Okay? So today we're going to take that 4x out and we're going to work backward. All right. So factor. What's factor mean? We're going to be dividing. Okay? So factor means divide. So my step 1. Okay? Look right here. I've written your steps up here on the board. Okay? Step 1, we're going to find our GCF. All right, so step 1 is GCF. So I want you to write GCF, and that's where we're going to write. So what's my GCF between 4 and 3?
3.
Okay. What's my GCF between 4 and 3?
Yeah, it's going to be 1.
Can 3 go into 3? Can 3 go into 4? No. What else can go into 3? 1. Can 1 go into 3? Can 1 go into 4? Yes. So what's my GCF? 1. Do I need to plug that in the calculator to know that it's 1? No. If you need to, that's okay, but right now I don't need to plug that in. Okay? Now, do they both have x in common?
Yes.
Yes. So x is going to be part of my greatest common factor because they both have it in common. Now, what's my smallest exponent? 2 or 1? 1. Okay, so that's my GCF. Okay, step 2 says, write the GCF outside the parentheses. Now, remember, this part right here is going to be part of my answer today. That's my answer. It's going to look like this. So I have to have parentheses. So I'm going to write my GCF 1x on the outside of my parentheses. You can write x or 1x, it's fine. Okay? For right now, I'm going to put the 1 out there to make it a little less confusing. Alright. Now, what's the opposite of multiplication? Dividing. Remember, factoring means dividing. Have I done any division yet? No. So step 3 says divide by GCF. So I'm going to take my GCF and I'm going to divide it to each term. Reality, you've already learned how to do this. Okay? If I cover this up, you've learned how to divide with variables and exponents. So I'm going to divide my big number. 4 divided by 1 is 4. Look up here, Brandon, right with me. And you're going to write your answer on the inside of the parentheses. If I divide the big numbers, what do I do with the little numbers? Subtract. 2 minus 1 is 1. So just regular x. Okay. Then I'm going to go to the second term. Negative 3 divided by 1 is negative 3. Subtract my exponents. 1 minus 1, 0. Do I write an x? No. And that's my answer. How could I check this? Huh? How could I check it? What's the opposite of factoring? Distributing. So how could I check this? What's 1x times 4x? 4x squared. What's 1x times negative 3? Negative 3x. Is that what I started with?
Yes.
Yes. So that's my answer. Any questions? Mind blown? All right, look at number 6. Okay, step 1. What's step 1 say? Step 1 right here says find GCF. So we're going to write GCF, and I need to know what my GCF is. Okay, do I need to plug this in the calculator? If you want to, you can. Okay, let's ask ourselves, what's my smallest number here? 6. Okay, so 6 has to be the greatest common factor in 6. Can 6 also go into 24?
Yes.
Yes. Okay, so what's my GCF? 6. Now I do want to plug it in the calculator so we can practice, because it's not always going to be that easy. So I'm going to do 24 divided by x, tab, 6 divided by x. And then where do I go? Table, Control T. Okay, do they both have 1 in common? Yes. Do they both have 2 in common? Yes. Do they have 3 in common? 4? No. 5? No. 6? Yes. So my GCF is going to be 6. Do they both have an x in common? Brandon, wake up. Yes. And my smallest exponent is 1. Okay, that's step 1. Find the GCF. Step 2. Write GCF outside parentheses. So here's my GCF, and I put it on the outside. Step 3. Divide by GCF. 6x, 6x. Okay, now we're going to divide. 24 divided by 6 is 4. Then I subtract the exponents. 2 minus 1. Just regular x. Good. Then I do the second term. 6 divided by 6. Positive 1. And I subtract my exponents. 1 minus 1. 0. Do I need an x? No. And that's my answer. How do I check it? Distribute. 6x times 6x, or 6x times 4x. 24, x squared, 6x times 1. Is that what my problem was? Yes, so I'm right. Brandon, pick your head up, please. Questions? Okay, number 7. Why is 7 different? 3 terms. What's step 1? Find the GCF. So I need to know the GCF. Now, again, my smallest number is what? 4. Can 4 go into 4? Can 4 go into 8? Can 4 go into 16? So my GCF is 4. Listen, quit talking over there. Do they all have x in common?
Yes.
Yes. So x is going to be part of my common factor. My smallest exponent is 1, so that's it. 4x. Donovan, you can ask in a nice tone.
No, because I said it quietly. He's like,
Okay, Levi, if Donovan asks you to do something, you need to listen because it is distracting. So please stop tapping your foot because you're still doing it. Please stop tapping your foot because you're still doing it. Thank you. Okay, that was step 1, find the GCF. Step 2, write GCF outside the parentheses. So 4x, parentheses. Step 3, divide by your GCF. Okay, each one at a time. 16 divided by 4. 4. Subtract your exponents. 3 minus 1. X squared. Then I go to the next term. Negative 8 divided by 4. Negative 2. Subtract your exponents. 2 minus 1. Regular x. Negative 4 divided by 4. Negative 1. 1 minus 1. 0. Don't need an x. Okay, how do I check it? Distribute. 4x times 4x squared. 16x cubed. 4x times negative 2x. Negative 8x squared. 4x times negative 1. Negative 4x. Am I right? Yeah. You need to check your work, yeah. Okay. Okay, number 8. Step 1. GCF. Okay, what's my smallest number? 5. Can 5 go into 5? Can 5 go into 20? Can 5 go into 10? Yes, my GCF is 5. Do they all have a y in common? Yes. And the smallest exponent? 1. Step 2, write your GCF outside the parentheses. Step 3, divide by your GCF. 5y. Okay, 10 divided by 5. 2. Subtract your exponents. 3 minus 1 is y squared. Stop. Okay, the next one. 20 divided by 5. Positive 4. 2 minus 1 is y. The last one, negative 5 divided by 5. Negative 1. 1 minus 1 is 0. Do I need a y? No, so that's my answer. And if I want to check it, 5y minus 2y squared is 10y cubed. 5y times 4y, positive 20y squared. 5y times negative 1, negative 5y. And we are all complete. Okay. We are. I want you to ask me 3 questions. Shh. 3 questions. Ask me 3 questions about this. Donovan, you have to stop. You're bigger than that.
Will there be more terms than 3?
Yeah, good question. Okay. Will I ever have to divide by more than just 3 terms? Yes, you might. Okay.
We have to do that right now.
What?
Each of us have to write.
No, you're asking me 3 as a total group.
Oh.
Who else has a question? That was a good question.
Do we have to?
Oh, I had a good person ask me a question earlier. Are you ready? Will there always be like this one on number 8? This is question 2. I'm going to speak for somebody else. Okay. Somebody had a good question. What if they all didn't contain y? Like, what if this 5 was just a 5 and it didn't have a y on there?
They would just.
Okay. If this 5, listen, if this 5 did not have a y on it, would they all have y in common?
No.
No. So could y be a part of my GCF if they didn't all have it in common?
No.
No. So what would my GCF be? Just a 5. So if I only had a 5, you would just do 10 divided by 5, 20 divided by 5, 5 divided by 5. Okay, third question right here.
Wait, you know how, like, if the 5 didn't go into the 20 or the 10, would we have to plug in all 3 of them into the calculator?
Yes. Okay, that's a good question. Oh, go ahead. Go ahead.
Do we have to not factor, but
Distribute?
yeah.
To make sure you got your answers right, you need to.
What if we know?
Especially on a test, okay? Because guess what? Your tests are gonna be multiple choice answers just like this. Well, what are you guys better at? Distributing or factoring?
I like that.
Factoring. You like factoring? Okay, well, a lot of us are better at distributing. Well, if your multiple choice answers are all looking like this, and you're better at distributing, then you should just distribute all multiple choice answers and see which one matches up with the question. Does that make sense? Okay. If you had a problem like this, A, B, C, D, okay? And your answer choices were 2x times x plus 4, 2x times x minus 4, negative 2x times x minus 4, negative 2x times x plus 4, right? And it wanted you to factor 2x squared minus 8x.
Not even go to the.
Yeah. Well, are you better at factoring right now? Or are you better at distributing each one of these? Distributing. Okay?
Well, that one.
So it's super important. Listen. Shh. It's super important that you still remember how to distribute because it's a lot easier to distribute than factor. And you can get all your answers like this on your test without actually having to factor. Even though it says factor this, you don't necessarily have to factor if you know how to distribute your answer choices. Does that make sense? Do we understand? Now, do you need to factor to be able to go to Algebra 2 and so on? Yes. So you still need to know how to do it like I taught you, but on your test, if it's multiple choice, you can always do the easier way for you. Okay? So, Ethan, to answer your question, do you need to distribute? Not necessarily to answer your question, but you need to distribute for the practice of being able to do it on your test. Got it? Okay. Did I answer that? Okay. Questions? Do what?
I think I just answered.
Good. Okay. All right, let's practice.
Can I go to the bathroom?